Now we will look at what happens when the axis of rotation is not the x-axis, but rather another horizontal line. So suppose we have this function f of x, and we're just looking at this simple region bounded by f of x and the x-axis. So of course, if we just rotated around the x-axis, this would be a very straightforward disk method. But suppose we instead rotate around another axis. Let's just say that this is y equals -3. We'll then notice instead of disk method, we have a space between the axis and the shape, so naturally this will become washer method or annulus method. The inner radius here, r of x, is just 3, the distance from the axis to the x-axis. And the outer radius, capital R of x, that's going to be f of x plus 3. And so the integral for the volume is going to be pi, integral from a to b, of f of x plus 3 squared minus 3 squared dx. Even stranger is if we're rotating it around a horizontal line that goes above the function. Okay, suppose this is the line y equals 4. Well, then the inner radius goes to f of x, and that inner radius, r of x, technically it would be 4 minus f of x. 4 is bigger than f of x, so 4 minus f of x is the inner radius. The outer radius is just the distance from the axis to the x-axis. So that would just be 4. So the outer radius is 4. And so this volume would be 4 squared minus 4 minus f of x squared dx. Similar things happen now when we have a region between two functions. So for example here, let's just say we'll generalize this. We'll say that y equals -a is the axis. And so now the inner radius goes to g, the outer radius goes to f, but we have to add a as part of this, so that our inner radius is going to be g of x plus a, and our outer radius is going to be f of x plus a. Similarly, if we have an axis of rotation way up here and we're rotating the figure around this axis, and let's just say that this is y equals positive k, just to give it a number. Well, now notice that the top function, f of x, that is actually the inner radius. So the inner radius is going to be k minus f of x, and the outer radius is going to be k minus g of x. And so this is how you find the inner and outer radius formulas when you're dealing with another axis. In the next video, I will show an example of one of these calculations.